In this video, we're going to wrap up our discussion of acid-base balance, and we're going to talk specifically about disorders of acid-base balance. Now, that does not mean that you need to know that if someone has an adrenal tumor, that that's going to cause metabolic alkalosis or respiratory acidosis or anything like that. Basically, what that means is if I give you a case study, you'll be able to diagnose whether or not someone has metabolic acidosis or alkalosis or something like that. And so this video, I'm going to show you how to do that. And so we have this single outcome for this video. So if you recall from previous lectures, we've got normal values for pH, carbon dioxide, and bicarbonate. Then we've also got acidotic measures as well as alkalotic measures. Remember that carbon dioxide is a weak acid, so if you have more carbon dioxide, you're going to be acidotic. And bicarbonate acts as a base, so if you have more bicarbonate present in your body, then you're going to be alkalotic. Okay, and then our normal pH is about 7.4, but we do have a range that we're in. And so let's go through a case study here. So you've got a 70-year-old male diabetic who has a long history of not taking his insulin. He has just been admitted to your unit and you receive the following blood test results. Okay, so he has a pH of 7.26, a carbon dioxide of 42, and a bicarbonate of 17. Now, before I go any further here, remember that these are case studies, okay? And when we do these case studies in class, I'm not going to have additional information for you. And the reason I say this is because, especially with pre-nursing students, I'll get questions, or I've gotten questions in the past as to what kind of diabetes, why isn't he taking his insulin, what else is going on? Okay, this is all the information that we have. And ultimately, when it comes to determining what kind of acid-base disorder he has, you just need to focus on the three values that we've given you. And ultimately, with these three values, we're going to answer three questions. What's the imbalance? What's causing the imbalance? And is there compensation? Okay, with compensation, basically we're saying if there's an issue with the respiratory system, are the kidneys compensating or vice versa? Okay, so the easiest way, or at least the way that I was taught to do this, involves a tic-tac-toe chart. Okay, in the top row, you just got acid, normal, and alkaline. What you do first is you go through each of the three values that you've been given and you put them in one of the columns, whether it's acid, normal, or alkaline. So in this case, pH is acidic, CO2 is normal, and bicarb is acidic as well. And based on this information, now you can answer these three questions. So what's the imbalance? When it comes to the imbalance, you just look, where is pH? And so in this case, since pH is acidic, we say this person has acidosis. So now you want to know what's causing this acidosis. Well, since bicarbonate is in the same column as pH, we would say this is a metabolic issue. Remember, bicarbonate is dealt with the kidneys, and we just consider that a metabolic issue. Then we have the third question, whether or not there's compensation occurring. So in other words, are the lungs doing something to try and get pH back to normal? In this case, we would say no, because our CO2 values are normal. In other words, I'm not breathing more or less to try and counteract my acidotic or this person's acidotic condition. And so ultimately what we would say is this person just has metabolic acidosis. Okay, so let's do another one. And I'm going to go through this. I'm going to give you a pause so you can diagnose them, and then we'll go through it together. So a 24-year-old female is brought into the emergency department following a motor vehicle accident. She sustained no injuries, but is extremely upset and anxious. She has been breathing rapidly since the crash and now feels faint. Her blood test results are as follows: a pH of 749, CO2 of 30, and bicarb of 23. Okay. One thing that I forgot to mention on the previous slide is that there will be times where I underline things. That will give you an idea of what might be going on. Okay, so in this case, this person is breathing rapidly. So that should give you a hint as to what they might be experiencing. Okay, so I want you to take a minute and answer these three questions and ultimately diagnose this person. Okay, so she has an alkaline pH, an alkaline CO2, but a normal bicarb. Okay, so this would mean she's got alkalosis. It's a respiratory alkalosis, but since bicarbonate is normal, there's no compensation. So we just say she's got respiratory alkalosis. Now this makes sense. She's anxious, she's breathing rapidly, which means she's getting rid of CO2. So her CO2 is low, which will cause an alkalosis, and this is a respiratory issue. Let's do another one. A 64-year-old male with a long history of COPD presents today with a slight fever. He complains of shortness of breath and coughing up sputum. His blood test results are a pH of 7.26, carbon dioxide of 52, and a bicarb of 34. Okay, again, take a minute, see if you can diagnose what this person has. So pH is acidic, CO2 is acidic, bicarbonate is alkaline. So this would mean they're acidotic, it's a respiratory acidosis, and in this case, there is partial compensation because the bicarb is an alkaline, it's out of its normal range. Okay, so we're in an acidotic condition, but we're holding on, or this person's holding on to bicarb to try and counteract that acidosis. Okay, now the reason that we say it's partial acidosis, or partial compensation, is because pH is still acidic. It's not back into that normal range. So the overall diagnosis would be respiratory acidosis with partial metabolic compensation. Next, we have a 48-year-old female who was diagnosed with an adrenal tumor causing excess secretion of aldosterone. Her blood test results are a pH of 748, CO2 of 51, bicarb of 29. What condition does this patient have? Her pH is alkaline, her CO2 is acidic, and her bicarb is also alkaline. So that means she's got metabolic alkalosis with partial compensation. So we would diagnose her as metabolic alkalosis with partial respiratory compensation. All right, next one. 45-year-old female was diagnosed with myasthenia gravis 5 years ago. She was recently admitted for evaluation and complains of increasing dyspnea. Remember what we talked about? We were talking about control of breathing with the respiratory system. Her blood test results are a pH of 736, CO2 of 50, bicarb of 34. What does this person have? So if we look at her pH, it's normal. CO2 is acidic, bicarb is alkaline. Okay, and so here, because pH is normal, that should let you know that we've got total compensation going on. But there's still an imbalance, and the reason we know that there's an imbalance is because CO2 is acidic and bicarb is alkaline. So we have to take basically an alternate pH, okay? In other words, is her pH closer to being acidic or alkaline? And in this case, 736, that's closer to being acidic. And so what we say is this person has acidosis. Since CO2 is in the same column as that alternate pH, we say that she has respiratory acidosis. But in this case, we have complete compensation. We know that because the bicarb is alkaline and the pH is normal. And so we'd say this person has respiratory acidosis with complete metabolic compensation. Now, it is possible that you can have everything in the acidic column or everything in the alkaline column. We're not going to do that in this class, but I want to make you aware of that. So you will just have examples like the ones that we went through in this video. And so at the end of this video, can you diagnose someone based on their pH, bicarbonate, and carbon dioxide values?